So, hello, Cyberland. My name's Marlin. The channel's Old Fart Hacks. And what I'm dinking with now is, if you recall in the last video, if you watched on trying to make a cut with the XY table on that Chinese, the Chinese XY table on the central machinery drill press, I couldn't get any way to adjust stably. And that's because, of course, this is the only thing I have to adjust with using this is mounted here, and then this is pressing on a lug. This right here is pressing on a lug on the bottom side of the drill press, shoving this down. And all that was doing was bending and just a mess. So I'm going to have to remake this piece out of aluminum, which will make it much more stable. The things I'm looking at here are the hole diameter here. I'll verify this over on the drill press shortly. And I think I already did that, to tell you the truth. And let's see if we come up with, basically the same number here. You'll see this, me measuring it over on the press with a micrometer. But that hole is 1.575 in diameter. This one, the only reason this is important is, again, 0.239. Writing down things down. So the question then comes, what's the distance between the center here and the center there? And that's what I get to figure out. So in the next part of this video, I really don't care about the hole diameter here aside, because I'm probably going to have to remake this shaft anyway. This is such a, after all, highly engineered part. Yeah, right. Just to get things locking down and so on. It'll thread into, this is loose here, and it's a mess. So I just need to know the center here to here, because that's the only thing that's really relevant. Where this lug is here. For instance, this line could have come in straight like this and put both parts in a straight line for their centers, Teach me to not look at the camera when I'm doing this. There's no reason why this has to have this offset in this direction and then an offset in that direction when the offset could be just straight through. So I've got to come up with this distance, and then we'll see about laying out the part. And then of course, you just need a clamping lug area here so you can clamp this thing on tightly. So I'll be back in a bit. Okay. So what it looks like we have here is 100 or 1.575 as the diameter of this collar area here. So that's what we'll work with. So the distance between these two holes is 1.5 inches. I measured, I checked, and so on and so forth. Worst case comes to worst, I've screwed it up, and I'll just, screw this hole to make anything fit. But the ring, or the hole here through the part, is 1.58 inches in diameter. This one is at 1.92, call it 0.2, really, 0.2 of an inch. There's a through hole here. Oh, I need to put the other half in. Silly me. But anyway, consider this hole going all the way through both sides of this. And then we'll put, of course, a screw running through and a nut on the other side to clamp this. And then the only problem we may run into is if we get enough clamp force here. But with this screw suitably tightened, it's going to be as tight as your average shrink fit. So that should work out. But this will allow us to have much more rigidity. There's more rigidity in this body than the way they had it, because basically this was a ring with a lug running off to the side, as you've seen, and that's, not as strong as a solid body setup. I'll be milling this out of that single block of aluminum that I showed you on the table earlier, and what I'll be doing is laying it out such that the table or the block cuts across here, and this edge will be one of the factory edges of that block. And then the fun part is to do this outside curve and so on and so forth. I don't know. Anyway, this will be drilled, and then I may just take a hacksaw and hacksaw out all the rest of this and then drill in that hole by hand somehow. Anyway, that's what's going to be going on.